Hey guys, and welcome to a new video in this neural networks and deep learning tutorial. In this video here, we're going to create an OCR model so we can actually read Captchas. So we're going to combine some different kind of things with recurrent neural networks and some CDC Loss so we can create this OCR model so we can read Captchas and do predictions on that. But first of all, remember to join the Discord server. I'll link to it down in the description here, and you can come join our community and talk about deep learning, neural networks, computer vision, and a lot of stuff like that. You can now also become a member of the channel here if you want to support the channel with a small monthly fee. Everything will go to create more and better quality content here on the channel. So in this video here, we're going to be reading these different kind of Captchas here with deep learning. So these are the images here, or these are some examples of the data set that we're actually going to create this OCR model on and train it on this data set here. So we have these different kind of letters and numbers here in our image, and then we have they're not really aligned at the same axis here, and we can also see this black line here that goes through both the letters and also the numbers. So we're going to use deep learning to actually read these Captchas here and then do predictions on what are the letters and what are the different kind of numbers in this Captchas here. So for example, here we can see that we have an E, we have an F, E, and then we have 62, and then we actually have the corresponding label up here. So we're going to create a neural network that loads in an image, and then we want to actually use deep learning and use our OCR model to do predictions on new data and new Captchas that it hasn't seen before, and then try to actually read what is actually happening in this image here. So what are the different kind of letters and what are the different kind of numbers in this Captcha here that we're passing through our neural network. So to actually be able to create this OCR model here, we're going to create it by using recurrent neural networks. So recurrent neural networks, we haven't really been over it in too much in this tutorial here, but I'll definitely cover that in the feature where we're going to go more into details what recurrent neural networks are and how we can use them for different kind of things. But in this video here, we're just going to have a quick overview over what it is and how we're going to use it to create an OCR model to do predictions on Captchas. So recurrent neural networks is really good at predicting what is coming next based on the previous inputs, because we have to actually have some kind of feedback loop, and we actually therefore have some memory due to the feedback loop, as we can see down at the bottom image. So we can see that we have a recurrent neural network where we have it actually looks like a feed-forward neural network as to the right, but the difference between a feed-forward neural network and a recurrent neural network is we can see that at the outputs we actually have this feedback back to the input again. So we actually have memory built into our recurrent neural network, which we don't have in our feed-forward neural network. So we can actually have we can actually do predictions on what is coming next based on the previous inputs, because we remember what it has actually output from that neuron as well in our recurrent neural network. So it's really good for solving problems that involves sequential data like speech and hand recognition. And this is the example that we're going to do in this OCR model here to actually read the Captchas, because we have these Captchas here, which is kind of handwritten digits and letters, and we actually have these sequential data here that we're going to read, and they're not really aligned, which is also really good when we're using recurrent neural networks and then CDC Loss. So for this project here, we're going to use something called CDC Loss, where we in the previous videos have mainly been using categorical cross entropy. So CDC Loss is a valuable operation to tackle sequence problems where timing is variable. So it's really good for speech and handwritten digits and numbers and recognizing those. So we don't have a need for aligned data set when we're using the CDC Loss, because every character does not need to be aligned at the exact location, which is the example with these Captchas that we have in this video here. So we don't really have aligned data in our images that we're going to read. So to explain the CDC Loss here is that if we, for example, have duplicates in an audio file or something like that, because it thinks that there's duplicates in the audio file because we don't have aligned data. And this is the exact same approach that we're taking with the Captchas that we have here, because our number and letters is not really aligned in the image that we're going to read from. So the idea behind here is that if we, for example, have duplicates here, or we don't have perfectly aligned data in our data set, Then we can actually have remove these duplicates here, but we can also actually like store duplicates where we want, if we have duplicates that we actually like want to keep. So in this example here, we're reading two H's here, we have an E, and then we have these tokens here that we can place in between here. So in this example here, we want to have this output here of hello, but we have two duplicates here that we don't want. We only want one H here at the beginning. Then we have an E, and then we have these three L's here, but we actually like want to keep the L's here. So in this example here, because there's no token in between here, we just combine all of these here, or like merge them all together. So we have one L, but in this case here with hello, we actually like want two hellos. So we place a token here in between, and then we can actually like keep the other L here as well, which is a merge of these two L's here. And then at the end here, we have the O. And then when we are done using these different kind of tokens here, we can actually like just remove them and filter them out. And then we have a E here, LLO, and then an output sequence here is actually like hello. So we can actually like have an input here where the data is not aligned. We can read some different kind of like false positives and stuff like that. And then we can do these different kind of operations. And then we can actually like end with the true output here, even though our data set is not aligned, or the data that we're passing through our neural network is not aligned, then we can still get the exact or like the right and true labels or true output at the end here as well, because we're using this CDC loss here as our loss function. So let's now jump into code here where we're actually like going to create an OCR model in this case here. So first of all here, we're just going to import different kind of frameworks and modules that we need for creating this model here. So first of all, we need to import the OS here. We need to use NumPy and also matplotlib to actually like plot the images that we have. So the captures that we're actually like going to read with our neural network, we're going to plot those with matplotlib. Then we're going to use something called pathlib and some collections here. And then we're going to use TensorFlow to actually like create our neural network that is going to actually like do predictions and reading these captures here. So if I run this block of code here, we will now create like load in the modules here that we want to use. Then we can go down here and load the actual data set with our capture images. So we're just going to curly from this GitHub repository here that I'm going to link in the description as well. So if you just run this here, it will just download the data set here. If we run a block of code here, we can now see that we're downloaded. We can see like how long time it took and stuff like that. And we can see that we have a total of almost like 9,000 images. So we have 9,000 capture images that we're going to train our neural network on. Then we can go down here and actually like do some pre-processing of the images and then split it into images and also the labels and also some characters, because we both need to encode and decode our actual images and the number and digits. So we can actually like operate with numbers instead of letters in our actual neural network. So we just encode that to actually like, so to letters and like numbers instead of we actually have these letters in our Captchas, and then we can actually like decode that back again later on when we're going to do predictions on it, because when we're operating with neural networks, it's better to have these numbers here that we can actually like pass through a neural network, and then it can train on those. So here we're just going to specify where our data is going to be stored. So we're just going to load it into Google Colab here. So we'll create a directory here in Google Colab, and we're going to store the images here in the Captchas images here version 2. Then we can get a list of all the images here. So we want to store all of our images in this variable here. And we also want to store all the labels in the labels variable here. So we both have our images and our labels loaded into Google Colab now. Then first of all here, we're just going to sort the images here, and we're going to load in from the data directory with this glob function here. So we're just going to load in all the PNG images that we actually like have in this directory here that we're specifying. Then we're just going in here and splitting the different kind of like information that we have in our images as well, because we both have our images and our labels in this data directory here. And then we're just going to split those labels into our labels variables here. So we actually like have the images and the corresponding labels as well now loaded into Google Colab, so we can pass that to our neural network before training. Then we can just print out here the number of images that we found and also the number of labels, which used to correspond to the number of images. Then we also have the number of unique characters down here. So down here, we actually like create a set here of the different kind of like labels that we have in our labels. And then we go through each character in our labels. So we actually like have each individual character stored as well in a set, and then we can actually like have that set stored here in the character. So we have a character which is a set of the individual characters that we actually like have in our labels. So we can actually like just read it in individual all the characters. So we're going to print out the characters that are present as well in an image. Then we're going to specify the batch size here. So the batch size when we're actually like training and doing validation of our model. We're going to specify the image width and the height here, which is just a 200 by 50 image here. Then down here, we're going to specify the downsample factor here, because we need to have this factor here by which the image is going to be downsampled. So we need to downsample our image before we're passing it through our convolutional blocks, because we don't really need that much information to be able to read these different kind of letters and digits in our image. So we're going to downscale our image as well. Then we're going to have a maximum length here of any capture in the data set. So we're actually like going to specify like for how long or like what is the maximum length of any capture in the data set. So we don't need to like look above look over all the pixels in our image. So if we run this block code here as well, we will now like pre-process the image here, or like load it in from the data directory, and we'll just specify these different kind of things here. And now we have a set with the characters for the labels. Then we can see here that we found a number of images here that we found was 1040, and we have the corresponding number of labels here as well, which is 1040. We can see here that we have a number of unique characters here, which is 19, and then we print out the characters that are present in our captchas as well. So we can see we have these 19 different kind of characters in our captchas. So these are the different kind of characters that we need to encode or like decode before we can do the rewards that when we're doing predictions. So we're actually like operating with numbers instead of characters in our code. So down here, we can actually like do the pre-processing of our data. So now we have loaded in our data, we have our images, and we also have our labels, and then we also have the characters that are present in our data set. Then we can pre-process the data here. So first of all here, as I talked about, we're going to do this encoding and decoding. So we're going to map here from characters to integers, because we want to use the integers for the different kind of characters that we have. So for example, a D here and N and M and G here, we want to have numbers representing those characters instead of the letters here. So we have the character to number, where we're just going to use the pre-processing like techniques or method that is already built into Keras. So we can just have this string lookup here. We just specify the characters that we want to like have in our vocabulary here, and the number of like indices here. So these are just the default parameters for this pre-processing function here. So we can actually like create we can map our characters to numbers, and then when we're going to reverse that or like decode it again at the end of the prediction, then we can actually like have a pre-processing here function again, where we take the number to the character, so we can actually like display what are we predicting with our neural network at the end. So these are just the two pre-processing functions that we're going to use. Then when we have all the images here, we're actually like going to split those images into our data set. So we have all the images stored here, and we want to split that into our training set and a validation set. So we have the training size here set to 0.9 here. So we want to use 90% of the images for our training set, and then 10% of the images for our validation set, and we set shuffle to true. So we just shuffle every time we're splitting the data. So we have this shuffle here and randomness when we're creating our model. So first of all here, we're going to get the total size of our data set, so we can see like how many images do we have in our data set. So that will be 90% of the 1040 images that we have in total in our data set. Then down here, we're going to like make these indices here, index arrays here, and then we're going to shuffle it if that is required. So we just have these indices here with the size here of our images, so the number of images. Then we go down here, and if we want to shuffle, we just use this shuffle function here from NumPy. So we have NumPy.random and then .shuffle, and then we're just going to shuffle all the indices here if you want to shuffle our training set and our validation set. Then we go down here and set the train samples here. So an integer where we have this size here times the train size. So we're actually like, this is the function that splits in our data set into our training set and also to our validation set. Then we just go down here and split the actual like data into our training and validation set by using these images here, where we go over the different kind of indices up to the number of train samples that we want, because we want to have the first like 90% of our images into our training data set, and then the rest of the 10% we want that into our validation data set. So now we actually like have all our data stored in this xtrain variable here. So all the images for our training set, we have this in the xtrain here, and the labels for the corresponding images in our training set is in this ytrain variable here. And then we have the same thing for our validation set. then we can just return those here from the function. So when we have actually like split the data, we're going to return that. So we can set it equal to something else down here. And then we actually like have now our data set both loaded in, and we have also pre-processed, we have shuffled it, and we both have it in our data set for the training images and the validation images. And then we can pass these different kind of like variables and our data set into the fit function, so we can actually like train our neural network. So down here, we have this encode single sample here. So we're just going to load in each individual sample, and then we're going to encode that for different kind of numbers and digits, because we need to like decode them so we can actually like get them into like characters to numbers. So first of all, here we're going to read in the image. So we're going to process one sample at a time. We're going to read in the image, then we're going to decode it and convert to grayscale, because we only need one channel in our image, because we're working with grayscale images where we just have these handwritten digits and letters. Then we can convert it to a float 32 here in NumPy, and then we're actually like going to convert that to like 0 to 0,1. So we actually like normalize our input data, so we have these numbers between 0 and 1, because they are better when we're training our actual neural network. Then we go down here and resize it to the desired size. So we want to have the desired size here, which was the image height and the image width. And then we actually also want to use the downsampling here later on as well. So then we can actually like transpose the image, because we want the time dimension to correspond to width of the image. So this is really important that we're going to do, and that we're transposing our image in this encode single sample function here. Then down here, we just call this map the characters here in the labels to numbers. So we're now working with numbers instead of letters. So we just call this function here that we already went over. And now we have our label here with all the numbers for the different kind of characters, and also the numbers in our labels. Then we're just going to return our image and the corresponding labels for that image. So now we have actually like encoded a single sample, and then we can just do that for all of the images in our training set and also in our validation set. So if we run this function here, we actually like do all the pre-processing of our data. So when we actually like want to use our images and our labels in TensorFlow and Keras, so we can just pass in our data set to the fit function, then first of all, we need to create these data set objects here. So we can just pass those objects here into the fit function in Keras and TensorFlow here. So to do that, we actually like just have our images here and the corresponding labels, and then we just use this from tensor slices here, and then it will actually like create these data set objects here and store it in the trained data set here. And then we also do the same thing for our validation set. So this is just like set up to actually like create these data set objects, so we can work with our images in TensorFlow and Keras. So if we run this block of code here, it will now create these objects here. And then we can go down here and visualize the data where we just want to like print out or like plot the different kind of like captures with their corresponding labels as well in the title. So I won't really go into details what these lines of code here does. It just visualizes the data that we have now loaded into these different kind of objects. So we can see here that we have these images that we saw in the slide. So we have our Captchas here, and then we have the corresponding label up above here and up above here. And these are the different kind of like images, and these are like the Captchas that we're going to pass through our neural network and train on. And then later on, we can do predictions on new Captchas that it hadn't seen before and try to predict these labels up on top here. So we can see that we have like a B and Y here, and then 23 here at the end, and this is the corresponding label up above here. So now we can actually create the actual OCR model that we're going to train on this data set that we're just loaded in and pre-processed. So as we already talked about, we're going to use recurrent neural networks with the CDC Loss function. So here we're just going to create this class here with our CDC layer. Then we have this call function down here that we can then use. So we're going to use the backend here for like the CDC batch cost here. So we specify like the loss here for this class here that we're going to use, and then we're going to use the backend here of Keras. And then we have this call function here, so we can actually like compute the training time loss value and add it to the layer using self.addLoss here. So these are just some formalities that we need to do here to be able to like run this call function here when we're going to use this CDC layer here later on to actually like train our neural network. Then when we have this CDC layer here, we can actually like go down here and build the actual model, which is a bit more interesting. So we have the input image here. We need to specify the layers.input here. And then we specify the shape, so we have the image size and image width, and then we have one channel here because we're operating with grayscale images. We specify the name here as image, and the D type here we want to use float 32, which is also the default in Keras and TensorFlow. We set the input here for the labels as well, and then we have the first convolutional block here. So we have different kind of convolutional blocks here in this example here. But the first one here is we have a two-dimensional convolutional layer. We have 32 filters or like kernels in the first convolutional layer here. We have a 3x3 kernel. We use the value activation function, and then we also specify like how we want to initialize our kernel parameters, which is just like default stuff as well down here. And then followed by a max pooling layer. So we're actually like taking the max values inside of a region. So we have this convolutional layer, we have a max pooling layer, then we have another convolutional layer, it's the exactly same one, but we instead of 32 kernels, we now have 64 kernels. And then at the end here, we're just doing max pooling again. So now we do 2 max pooling with pool size and strides 2. So we have actually like downsample our feature maps to be 4 times smaller. Because we're using this max pooling here and we're just looking at a region, and then we're taking the maximum value in that region that we're using, and then we use that later on, or that is our output from the max pooling layer. So now we can actually have this new shape here, which is the image width floor division by 4, and also the image height here, floor division by 4, and then we multiply that by 63 here. And the reason we multiply by 64 here is that the number of filters in the last layer is 64. And then we reshape accordingly before we're passing the output to the recurrent neural network part of the model. So now we have just created our convolutional neural network part. So now we're going to create the actual recurrent neural network. So we actually have the inputs fed back to the the outputs from our recurrent neural network fed back to the inputs of that network as well. So we're remembering the inputs in our neural networks as well. So down here, we're just going to have this reshaping here that we just talked about. Then we have a dense layer here with 64 neurons. We have some dropout, and then we're going to actually create our recurrent neural networks here, where we use something called long short-term memory. So this is just how we specify a recurrent layer here in Keras and TensorFlow. We want 128 here and 64 down here. So we just have 2 layers here in our recurrent neural network here. And we can also see that we're going to use some dropout for our recurrent neural networks here as well. Then when we have both our convolutional neural network and our recurrent neural network, then we can actually go down here and create our output layer. So the number of neurons that we want in our output layer is actually like the number of characters plus 1. Because we want to predict, like we want to be able to, every time we load in like a number or like a digit or a character, we want to predict that or like what class that is. So we need like a number, or like we need a number for each of the classes that we actually have available to do predictions on. So that's why we have the length of the characters here plus 1. We're using the softmax function, so we just get a probability of what character we're actually like reading in our captcha. And then down here, we can actually like add the CDC layer for calculating the CDC loss in this example here. So this is just a loss function that we're going to specify. So we have this CDC layer here at the output layer here as well. Then we can define our model here, where we just set the inputs equal to like the input images and the labels, and the outputs equal to the outputs that we just defined here with the CDC loss. Then we can now specify the optimizer that we want to use when we are training our OCR model here. So we want to use the atom optimizer. We're not specifying any learning rate, so we're just using the default one, which is 0.001. Now when we have our actually like chosen our optimizer, we have created a whole model, then we can compile that model together with our optimizer here. So we specify the optimizer here to the OPT here, which is the atom optimizer that we have up here. Then we compile a model, because then we put everything together. We're building our neural network, and then we're compiling it with this optimizer here and a specific learning rate. And then in this function here, we're just going to return this model here. Then down here at the end, we can actually like get the model. So we call this function here build model. It will return the model. So it will return all these different kind of layers here. It will compile it as well with an optimizer, and then we can do a summary of it to see like what is actually like really going on in the different kind of layers, and if it loaded in the correct layers, and also if it compiled it correctly. So if we run this block of code here, it will now create the whole neural network. We will get this summary here out as well, where we can see the individual layers in our OCR model. So we have the convolutional layer here, max pooling layer, convolutional layer, max pooling. Then we have like a dense layer dropout. We have our two recurrent neural network or two recurrent layers. And then we have our CDC layer here, and then we CDC layer down here. And then we can actually like do predictions here at the end, where we have this dense layer here at the end, which is the actual classes that we're going to predict. So we can see we have a total number of parameters of a bit more above like 400,000. So these are the different kind of parameters that is going to be tuned and tweaked on when we're actually like training on neural networks. So we're able to read these captchas here and then later on do predictions on them. So now we're going to actually like train the neural network as we have done with all the other neural networks throughout the tutorial here. So we specify the number of epochs we want to stop early if our neural network is not improving anymore. We set that equal to 10. So if our neural network hasn't improved for 10 epochs, then it will just like terminate the training process, and it will restore the best model parameters or like the best model's weights. We're specifying this early stopping here from the built-in callback functions from Keras. And we want to monitor the validation loss. So when the validation loss is not increasing anymore, then we're just terminating the training process here. Then the function to actually like train the neural network here is this fit function. We pass in our training set. We set our validation data here to our validation set. We set the number of epochs to 100 here, and then we just use the callback functions here. So the only callback function we want to use is the early stopping callback function that we specified up here. So when we run this block of code here, we will now do the whole training of our model on the data set that we have loaded in and pre-processed beforehand. So our neural network is now done training now, and we can see that it has now trained for 100 epochs. And we can also see that we hit a fairly low loss here for both our training loss and also for our validation loss. And it also decreases over time. It started fairly high. As we can see down here, if we're actually like going to plot the history of the loss and also the validation loss. So if I run this block of code here, it would actually like plot the training process here for our OCR model. And we can see here for the number of epochs here. So we run from 0 to 100 epochs. And then we can see how the loss here is decreasing over the number of epochs. So we can see here that when we hit like around like 8 to 10 epochs here, we can see that our loss is really decreasing a lot, because we start to learn like how we can actually like do predictions, and like we actually learn about our data in our recurrent neural network and also in our convolutional layers. But it's mostly in the recurrent neural networks where we use like this feedback loop from our outputs to our inputs again. So that's pretty much it for this video here, guys. We've been over like how we can set up these different kind of convolutional layers, our recurrent neural network, and also like what is CDC loss is and how we can use it. And then we created this neural network here with the data that we loaded in. We pre-process data, and then in the next video, we're actually like going to use this model that we have now trained to do actual predictions with the neural network. See, can it really do predictions on new captchas that it hasn't seen before from our test set. So thank you guys for watching this video here, and remember to hit the subscribe button and bell notification under the video here, and also like this video here if you like the content and you want more in the future. I'm currently also doing a computer vision tutorial where we're talking about like different kind of stuff with image operations, stereo vision, camera calibration, a lot of stuff like that. So if you're interested in computer vision as well, I'll link to the tutorial up here, or else I'll see you next video, guys. Bye for now.